And this video is going to be about multiplying and dividing mixed numbers. So when we say mixed numbers, we're talking about numbers that have both a whole number and a fraction part to them. Our first example is 3 3/5 times 3 5/6. So the first thing I'm going to want to do is I'm going to take these mixed numbers, because as we can see they're both mixed numbers, both have a whole number part to them and both have a fraction part to them. I'm just going to turn them into improper fractions. The reason I'd like to do that is because we know that the way that we multiply fractions is we multiply the numerators and we multiply the denominators. The problem being is that then we've also got whole numbers sort of in the mix, and that makes it more complicated for us to multiply them like this. If we turn them into improper fractions, they'll just have a numerator and denominator, and we can just do it the way that we normally do. So if I'm looking at the first one there, I have 3 3/5. So the 3 is telling me I have 3 wholes, and if we look at the fraction, the denominator, the 5, is telling me that each of those wholes is cut into 5 pieces. So if I have 3 wholes and they're all cut into 5 pieces, then I'm going to end up with 15. So I have 15 pieces just from my whole numbers, and I've got 3 extra pieces. So 15 plus 3 gives me 18 pieces of 5, so 18/5. Then we're going to do the same thing for 3 5/6. So again, that denominator, the 6, is telling us that our whole pieces are cut into 6 pieces. So if I have 3 wholes and they each have 6 pieces to them, that's 3 times 6, which is 18. Plus I've got an extra 5 pieces there, so 18 plus 5 is 23, so 23/6. Next we're going to multiply. So I'm going to multiply my numerators and multiply my denominators. So 18 times 23, that's a fair bit. I could break it down a lot of different ways probably. I think what I'm going to do is multiply 18 by 20 and then 18 by 3. So I know that 18 times 20, well I could do 18 times 10, which is 180. So 18 times 20, because 20 is double 10, should be double that. So 18 times 20 should be 360. Then I've got 18 times 3. So I would double 18 is 36, and then 18 more would be 54. So if I combine those, my 360 plus 54, I get 414 for my numerator. For my denominator, I'm just going to do 5 times 6, which is 30. Next, I'm going to try to simplify my fraction. So for that, I'm thinking, how many times does 30 fit into 414? So just as an estimate, one of the first thing I'm thinking in my head is kind of ignoring the last 2 digits and thinking, how many times does 3 go into 41? And that would be, it would go in 13 times evenly. So if I sort of think about that in my head, 13 times 30, well 13 times 3 is 39, so 13 times 30 would be 390. And if I think about it, I can't add another 30 to fit into 414, so it'll fit, 30 will fit into 414 13 times evenly. So I want to figure out what's left over. I'm going to do 414 take away 390. So in my head I'm thinking, well, 414 is 14 away from 400, and then 390 is 10 away from 400. So 10 plus 14 is 24. So 414 take away 390 is 24. Next I'm going to look at that 24 over 30 and think, is that in lowest terms? Because if I'm looking at the 24 and I'm looking at the 30, I'm pretty sure that we can divide both of those by the same number because 24 and 30 are both multiples of 6. So I'm going to do that next. I'm going to divide both of those by 6. And that gives me 13 4/5. I'm actually just going to go through this problem and show you another strategy because for this we simplified at the end. Sometimes you can actually simplify closer to the beginning, and that may be more efficient for you. So I'm starting with the same problem. And I'm going to start the same way I turned my mixed numbers into improper fractions, so that part is just the same. But at this point, I'm actually going to try to simplify now before I get into those big numbers. And when I might choose to do that is when we've got the things like 18 times 23, because that gave us 414. That was a lot to deal with. So what I want to look for is look if any of my numerators are multiples of my denominators. So my first denominator is 5, and if I look 18 and 23, neither of them are multiples of 5, so 5 isn't going to work out for me. But then I've got 18 and 23, and then I'm looking at the 6 and looking at the 18 and the 23. The 23 isn't good, but 18 is a multiple of 6. So what I'm going to do is I'm going to divide both of those by 6 right now. So when I divide 18 by 6, I get 3, and when I divide 6 by 6, I get 1. This also works like if they're both multiples of the same number. So maybe even if I didn't have 18, if I had 20, well, 20 and 6 are both divisible by 2, so I could divide both of them by 2 at this stage. But anyway, so that leaves me now, instead of doing 18 fifths times 23 sixths, I'm just going to go 3 fifths times 23. So a little bit more manageable now, right? So when I do 3 times 23, in my head I'd probably just go 3 groups of 20 gives me 60, and 3 groups of 3 gives me 9. So that's 69, and then 5 times 1 is just 5. So I have 69 over 5, and then I'm going to think, how many times can 5 fit into 69? Well, I know that it can fit in 13 times evenly for 65, and then there's 4 left over. So I get the same answer, 13 and 4 fifths. So this is just two different strategies in terms of whether you simplify towards the start of the question or at the end. And you're free to use whichever one makes the most sense to you. Next, we're looking at dividing, and we've got the example 7 1/3 divided by 4 2/3. So the first thing we're going to do is turn our mixed numbers into improper fractions. Again, just because the algorithm we have for dividing deals with numerators and denominators and doesn't really factor in the whole number thing. So if we have 7 1/3, that means we have 7 wholes and they're all cut into 3 pieces. If we have 7 groups of 3, we have 21. Then we've got the 1/3 extra, so we have 22 thirds. Then we've got 4 2/3. So if we have 4 wholes cut into 3 pieces, we have 4 groups of 3. That makes 12, and then we've got 2 extras, so we've got 14. Now remember, when we're dividing, we have an algorithm for that, and that is the first fraction stays the same. First fraction always stays the same. We change our dividing to multiplying, and then our second fraction, we take the reciprocal. That means we switch the numerator and the denominator. And next, I'm actually going to use the same strategy I just used in the last example, because right away I notice I've got a 3 in the numerator and a 3 in the denominator. So I'm going to divide both of those by 3. So 3 divided by 3 is 1, in both spots. So then we've got 22 times 1 and 14 times 1. So we should get 22 over 14. Next, we see that the numerator is bigger than the denominator, so we're going to turn that into a mixed number. So if I'm thinking, how many times does 14 go into 22? Well, one group of 14 is 14. 2 groups of 14 is 28. That's too much. So it only goes in one time. So there's only one whole. And then so if I have 14 of my pieces go together to make one whole, then I have 8 other pieces left over. So that gives me 1 8/14. Then if I'm looking at 8 over 14, I notice that 8 and 14 are both even numbers, so they're both divisible by 2. So I'm going to divide those by 2 to make sure that my fraction is in simplest form. And then I've got 1 4/7 as my answer. So a lot to remember here. So we notice both multiplying and dividing, we're going to start by turning our mixed numbers into improper fractions, and from there we're just going to follow the same steps that we would if we were just multiplying or dividing any other fraction. So for multiplying, we multiply the numerators and the denominators. For dividing, we keep the first one the same, switch the dividing to multiplying, and then take the reciprocal of the second one. And again, reciprocal means we're swapping the numerator and the denominator.